everyone. So this week we are going to discuss two string related problems, string problems. Okay. So here is the first one. Okay. Given a substring, search for the occurrence of a word W. Okay. Wait. Yeah. Within a main very long string S. Okay. S is very long, very big string. Okay. If found, return the start index of the S. So, oh, it should be starting. So output should be start index actually, not true false. I should change it. So, okay, found. We will see what is the start index. Okay. Why can I type? I can't even type here. Just a minute. What happened to this OneNote? Okay, found and start index. Start index. We'll figure that out. Not found. So probably start index. Um, that should be -1. Okay, so very simple, right? If you have this, right, if you have this find feature is very simplest feature that is available in everywhere, right? So let's say this is a string, copy, and I am putting in a notepad. Okay, it is the thing. Now if I find, let's say I want to find this word, right? What we do is we simply go here and we will say control F and hit here, right? We found it. See that? So the ask here is how to do this. So how that contains, like basically in Java there is a contains method, and in C sharp also there is a, I think, find, or there is different uh, SDK methods available to find whether the particular string is part of the entire big document or not, or big document or big string or not, right? Very simple. But how this was implemented behind the scenes, that is the main question here. So let's say if I say like K, they could not find this string, right? So very quick, how this happened. So how that, so even the string is really big, this can work, right? So it doesn't matter one line or thousand lines, how it can be done very quickly, right? So what is the algorithm behind that? Any ideas? So here is the, it is like finding a needle in the haystack. It's very toughest thing, right? Like because it, just imagine we have that string is really big, right? So we need to find every character needs to match, right? In the notepad, let's say we have that again. So first we have ABCD. We have AB here, ABC here, and we have ABCD also here. But then we need ABD. There is AB, the entire string was matched, but again the last character did not match. Again, you need to start with the next character, and again you have to start with the first character here, ABCD, right? So this way we start in every situation we need to start comparing the characters, right? How this can be done, what is the logic behind that? So it is called a needle in the haystack. So needle in the haystack is something is almost impossible to find because it is hidden among so many other things. So that's what is
Bottom.
I'm trying to open a couple of images just to show you. It's still very slow. Yeah, see this. It's a needle in the haystack. So here is the haystack. We all know this, right? So how to find this needle? It's very tough, isn't it? Right? So this is what they, in English they called, if you can't, it says needle in the haystack. Haystack. So how to do that? So what is the haystack here? Haystack is the big word. This is the very big. It could be very long, and this is a small needle you are finding. You just want to find this small string in this really big long string. Okay, so how to do this? Any ideas?
Traversing the string from starting to ending.
Traversing the string from
Checking.
starting to end, and also we have to check with each character, right? Here and here,
Yes.
and as long as it matches, then we'll be good. That's a basic algorithm. That's navy algorithm, I would say, because that's the only way to do it, right? So we need to find, let's say you are traversing this entire string. First you compare with the first character with this first character. If it is matching, then you enter into the another loop where you will see how far you are matching this, right? So if A and A matched here, now you enter into the second loop where you say, okay, let's see how far we can go. A, B, C, A, B, C. Next one is space character. Space character did not match with D, right? Now you say, okay, this is not
Mm.
the right start. You go back to A again. Okay, let's find A again. So now you done with A. When you start with the first character A, you did not find the entire string. Now you're going to start with B. Is B and A matching? No. Now you start with C. Is C and A matching? No. Now you start with empty character, right? This is empty space. Is the empty space matching with A? No. Now you start with this A. Is this A matching with this A? Yes. Again, you enter into the second loop where you start how many characters are matching. A, B, C, D, A, B is matching all the way here. Then NP character came and which did not match with D. Then you are done, right? You can't even proceed. Now you start with the next character which is B. That's what you're saying, right? So every character you have to and we have to restart with A again because we did not find the string. We have to restart again with the first character. You guys following so far?
Yes.
That is the
Eh,
algorithm
Yes,
here.
yes.
It's just a couple of loops. It's complicated in the sense writing the algorithm is not easy, but the logic is here. This everyone can say, okay, that's the way to do it. So but there could be a better way. What is the complexity here? The worst case complexity, worst case performance of this algorithm is order of kn, where k is the length of the substring to be found, and n is the length of the string. So what are we doing here? Basically, we are for every character, okay, we are trying to match this entire string, right? So in the worst case, what will happen is order of kn. So that means for every character here, you are going to match with entire string here. That is the worst case. So there is a another complex algorithm called KMP algorithm, which is better worst case performance than the other one, which is order of k plus n. So we already know k into n is always bigger than k plus n, right? So but it is very complicated. It's not that easy. I spent more than like 3 4 days. Not this time around 5 years ago when I was preparing. I'm so interested. I spent more than 3 4 days to understand the whole algorithm. The KMP algorithm is called Kunt Mori's Pat Pratt algorithm. So very big Wikipedia is there. They try to explain everything because this is a big challenge, right? So it's not every editor notepad or any algorithm, like wherever you have that find algorithm is there, right? So even in the browsers you can just find for any
Yeah.
word. This is very popular and very efficient. This algorithm needs to be very efficient, right? But that's why they have this
Mm.
specialized algorithm. So example, they have very detailed explanation about this. I spent 3 4 days to understand the algorithm. So we need to create some tables, and looking into the tables, it's just like um, what is that, greedy algorithms, I think. Is it greedy or let me find. So there are certain algorithms where we have, yeah, is it, yeah, dynamic programming. I think in the dynamic programming, what we do is we'll create a separate storage, we'll create a temporary tables, we'll create temporary data to process. Similarly, we'll do the same thing here. They will create some temporary tables. So basically, it is better algorithm than what we just discussed. Okay, so rather than starting again from the beginning, like let's say you did not find a, you did not find the word, right? So it will start at the better position rather than starting from B, right? So you want A, B, C,
Yeah.
D, A, B, D. So there is no point of taking B, C and comparing with A, B. So we need to start at the right, next right position. That's what it is. So I would encourage, go through this algorithm and and understand. So the basic algorithm we just discussed, right? So I am going to show you that. I coded both actually. I coded the normal algorithm and I also have this algorithm in the code link. I will open it and show you. Okay, here is the thing. Search for the occurrence of the word, a word, okay, in the main very long string. And here is the algorithm. So here is the input text, here is the search text, and get substring, get substring index. This is the algorithm I wrote. So first one is input, second one is the search text, whatever the text we want to search. And here is the KMP search. So KMP search also there. So but it's not easy to understand. So here is the KMP search. KMP search has two methods. Okay, using KMP algorithm has two methods here. So let's go through the normal one first because it's not easy to go through this KMP algorithm. So let's go through the normal one. So what we do, as we discussed, haystack. Haystack is the input, okay, really big input. And needle is the string that we want to find. Okay, are we clear? So now, if the needle is empty or haystack is empty, you simply return -1. You did not provide any proper input, right? So you are asking me to find empty, then simply return say -1. That's the index. Now, what we do is, as Tarun you said, first we need to start with the zero index of the haystack and go all the way to the end of the string for the big string, right? Actually, we look at this. This is a simple logic. We no need to go all the way to the end of the haystack. We just need to go to the haystack length minus needle dot length. That means, so we need to compare. We know how many variables here, how many characters here. One, two, three, four, five, six, seven, right? So we need to compare seven characters from here, seven characters from B, seven characters from C, and all the way to seven characters from here, right? One, two, three, four, five, six, seven. So let's see if the last seven characters are matches with these characters, right? We no need to compare these things anyway. C, D, A, B, D, because it's only six characters. You no need to compare with D, A, B, D, E, isn't it? Let's say you did not find this character all the way here. Now you want to compare with this. What is the point? You know, this is the six characters will not, five characters will not match with the six characters anyway, right?
Yes, Suresh.
So that's why
Yes, Suresh.
the for loop is always from 0 to haystack length minus needle dot length. Just to deduct that or subtract the needle length, then you can find until where you want to go. Okay. Yeah, it looks like network problem for um, this guy. I think he is going to join Tarun. So Arshad, are you following so far? Arshad?
Yeah, Suresh. It's
Okay.
it's clear. Like when
Cool.
the like in the main string, if like you're telling, before the length of the substring, like if the substring is 5 and the length, like we should compare till end minus 5 position. You are explaining
Exactly.
that only, right?
Exactly. Yeah.
Yeah.
So that it will start from the beginning, 0th index, all the way to the substring, length of the substring. So
Yeah.
it could find before that, or we don't know whether that will be the worst case. The last you will find all those last six characters with this. Let's say these are seven characters, right? So last seven characters will be compared,
Hmm.
and finally, if it equals, you will get the index. Otherwise, you will get -1. Similarly, this one. So ABC, ABC. This ABC, ABC is not here. We have ABC here. We have ABCDAB, and we have ABCDABC. So you never find this word, and finally it will compare with last six characters here, and finally it says no, we did not find it, right? So that's the
Suresh,
logic.
like
Yeah.
there is a network issue. Can't able to see your screen.
Oh, there is a network issue. Oh, okay. I can do one thing. I can share the code. You can also open on your window. Okay, you can hear me, right? Tarun, you can hear me, right? Yeah.
He's on mute. Taruni are on mute. Hmm.
Yeah.
Yes, sir.
Yeah, I shared the code link, so you can open that in your browser as well. If you can't see it, or should I share it again? Do you want me to share, or
Yeah, share it, Suresh.
yeah? Let's see.
Arshad, can you confirm like is it problem with me or you also?
I can see the screen and code, Tarun. I think you are facing the issue.
Okay.
Okay,
Now
now
are you
now
able to
I'm
see?
sharing.
Now he's sharing again.
Yeah, I shared again. Okay, will you be able to see now, Tarun? Oh, Tarun joined
He
again.
is like
Yeah,
dropped again.
yeah, he dropped. Maybe he has some uh, network issues. Yeah. So now let's go with the logic. So as we said, this is the top level logic, right? Let me send the code
Yeah.
link in the let me send the code link in the Discord as well, if in case. See, code link here. Why it is dropping as a string, as an image? It is opening as an image. So okay, I don't know. Okay, let's see. Yeah. Hey Tarun.
It's okay.
Yeah, Tarun. I shared the code link. If in case you can also open on your side. Okay. If you can't access our screen. Tarun, can you hear us?
Yes, Suresh, it's fine now. You can
Uh,
continue.
can you see my screen as well?
Yes, yes.
Okay, very good, very good. So here is the, as we said, first loop is for the each character in the haystack in the given input. Okay, now next one is k equal to 1. Let's see what is that k. And start index equal to -1. So we are assuming the start index is -1. Finally, we will find the actual start index. Okay. Now, what are we doing here is haystack of I equal to needle of 0. So if the needle of 0 means the first character matches with haystack of I. If the both first characters are matching, okay, then we will enter into the actual loop here. Another condition. So now start index could be I. we want to if it matches, right, if it matches the entire string, then that could be start index, right? So that's why we are putting that start index I value in a variable. Okay, now we will go from that I plus 1 all the way to haystack dot length. So haystack, let's say the we will go again to the end of the string. We don't need to go all the way end, but just for the sake we are just having this for loop. So we will start from here. So you find a here, this a is matching with this a. Now from b onwards we will try to find rest of the string for this rest of the string here, b c d a b d, right? That's what we are trying here. From I plus 1 go to the end. Now if k is less than needle dot length, k equal to 1. Why we set k equal to 1? Because we already matched one character. Okay. Now k already matched one character, but is that k is still less than the needle length? If the needle length is 6 or 5, it is still less than. We still need to find another. If let's say the needle length is 7, we found one character which is matching. Now we need to find 6 more characters, right? Now what we do is, if haystack of j is equal to needle of k, needle of k is 1.
Suresh,
Yeah.
I think the if condition in line number 50 is not required, right? I mean, if we can break from inside only, na. I mean, however, it will be less than the needle dot length only.
Hmm.
Oh, like you can directly compare there. J
That's a
equal
good
to I
point.
plus 1, j less than I plus needle plus length,
J equal to I plus 1. J less than.
j less j less than I plus needle dot length. Like, we'll compare only till there, right? If
Hmm.
you'll compare only till there, then now you're keeping that loop till the end of the haystack.
Which
But
is not required.
as soon as k will be equal to needle dot length, you're breaking it again.
Yes. Yes.
So in place of the 50th if condition, you can directly keep I plus, like, j less than
Hmm. Needle
I
dot length,
plus
probably.
I plus needle dot length, I suppose. I
Hmm. Correct.
plus
Correct. Yeah, you are right. You are
needle
right.
dot
I plus
I
needle dot
plus needle
length
dot length minus one,
minus 1. Yeah,
because
because we already matched one
yeah,
element here. Yes, that's right.
one element.
Yeah, that could be
Okay,
possible.
that's like I was like thinking why is, like, that is one point which I got. Yeah,
Yeah, that is also, I think, good changes. We can definitely try that. So what we're doing here is, as long
yeah,
as k is less than needle dot length, we are comparing the next two characters, right?
yeah,
So
yeah.
if you change the if condition here as you suggested, we may not need this condition. Yes, then we will
Yes.
simply check these two conditions, and
Compare this.
we'll increment the k.
Yeah,
Now, if both characters are matching, then we are breaking. If we did not match, we no need to do this. That's why, let's say if we encounter a character which is not even in the needle, that means we can entirely break this loop, right?
yeah.
And then if the k is less than, if the another problem here is, if k becomes needle dot length, or I'm just looking how it will break here. If k
We
is
can stop there. There
It will break
itself.
when k
Now,
value is greater than length.
Yeah, if k value is greater than length, we found all the characters, and when it will come here and we'll compare. If k equal to needle dot length, we found all the characters of the needle in the haystack, so we found it. So simply we'll return the start index, right? Otherwise minus one.
yeah,
Yeah.
Or else we can write like when we got fulfilled with the needle length, the next value will be not equal to j, and it will automatically break out of the loop.
Yeah. So you're saying here in this loop,
Yeah.
yeah, we can do that as well. I think I need to, in order to edit, I need to log in. So we can edit. Do you guys want to try the editing? Yeah, let's edit the
We
algorithm as
can
it is.
continuously.
We can edit it. So that's a good optimizations we can try. Oh, it's asking me to log in. I don't know. It's very slow for me. Let's see. Yeah, you guys write the logic in the meantime. That for loops, we'll put it there and check. We'll verify. Wow, it's very slow here. Because in order to edit, I need to modify. Actually, I should open here. Another thing, what I can do is I can open locally. This will be faster. Okay, it's a string algorithm. String substring here. Okay, this one. Let's see. Let's see, man. Both are opening. Okay, we'll go to the strings algorithms and okay. Uh, substring, yeah, substring index, right? This is the one we are talking. Substring index did not open here too. Okay, we finally able to open here, and we also able to open here. So we'll try here. So what you guys saying is we can change this, right? Let's do one more function to optimize. Okay. Oh my God, it's giving a lot of headaches here. Let's do here. Okay. Here is the substring algorithm, right? Get substring index. Let's see if we can optimize more. Okay. This is a get substring index 2. And what you saying, Arshad? So this is fine. The first condition, if for loop is fine, and this if condition is also fine. So here, what you're saying here is we can start from I plus 1, right? All the way to I plus, is that needle dot length, right? Let's say needle is 2. Okay. So now you found first characters here. Now you are finding the next character from that position plus needle dot length. Let's say if it is first,
Yeah.
it will be second, and 2 plus length is 2, it will be 4. I think we need to do minus 1, as you said, right? We'll go there all the way from I plus 1 to I plus needle dot length minus 1. Now we will compare those two characters. If, okay, if no, we don't need this, right? We are assuming this may not be required. Now, if both the hashtag has haystack of j is equal to the needle of k plus plus. If the next character matches k plus plus. If we did not match any of these characters, we'll just break the loop because you found something which is not matching, right? Now we'll
Mm.
compare, is the k equal to needle dot length? Okay. If k equal to the needle dot length, that means we find all the characters. Okay. So then return the start index. Otherwise, go back to the top again and start with the next character in the haystack. It looks like good for me. We can try. Okay, here is the index. Let's see. Rather than KMP search, we can use this one. Okay, index and index one. Let's see. Index and index with KMP. It's not KMP search. It is our optimized one. Okay, let's see. Yeah, 15, 15. Minus 1, minus 1.
Line number 20, you did not change, Suresh.
Line number 20.
Same function it is calling.
Oh, sorry. That's a,
Two, you gave the
that,
name to.
that's a good point. Let's see what happens now. Oh, we are getting minus 1 with our logic. Why? See, we have some bugs here. Hmm, what is wrong? So I plus j plus plus I plus needle length minus 1. Or maybe equal here, or maybe let's see if we can remove minus 1 will be correct.
Okay, you gave less than.
Yeah, now we got it,
Yeah,
right?
less than or equals to
Yeah,
minus
easily.
1.
Yeah,
But yeah,
either less than or equal or something like just less than
less than I
I
plus
plus
needle.
needle dot length minus 1. Needle
Yeah,
dot length basically. Yeah. So here we eliminated one additional
if condition.
condition, unnecessary. We don't need this. So basically, we don't need to go all the way to the end of this anyway. It won't go anyway. It will just break.
It won't go, it will break inside that if
Yeah,
near 60.
near 6. Yeah, here. But
Uh,
wait. It will go all the way. Oh, no, no, no. It will go as long as they are matching, right?
yeah,
So if any situation, if you find something which is not matching, it will break here.
Mm.
So
Mm.
this will break because if k equal to needle dot length. So in our situation, if the k equal to needle dot length, that will be taken care by the for loop itself. This one. We are checking only next 7 characters.
yes.
Right? Basically what we're doing here
Huh,
is the for loop will go, let's say A and this A matching. Okay. Now in the next for loop, we are only going from B to 1, 2, 3, 4, 5, 6. We are going only till here and matching when trying to compare with the B, ABD. Right? That's what the second for loop.
yes.
Second for loop is basically rather than saying hey go all the way here, we don't need to go all the way. We just need to go how many characters in the given input. In the rest of the inputs. The rest of the characters are 6 characters and take the next 6 characters here BC space ABC. So BC space ABC and take these 6 characters and try to compare with this rest of the 6 characters. Okay, that's what we are trying here. That's the main algorithm here. Okay, so very simple. I would definitely practice so that you can able to write in the interview, right? So it's a matter of couple of um, variables and then two for loops here. Okay. Now coming to the KMP, it's complicated. I don't think we should go here. It's a it takes a lot of time as well to understand this whole algorithm. Look at this. The KMP search requires couple of variables and also get partial matching table. This is the get partial matching table. This will create a separate table for comparison, and then that table will be used for the actual comparison. So a lot of if conditions and while loops and but it is a good algorithm. So
Like,
yeah.
can you say in short form, like, what is the approach
Approach for KMP algorithm, you mean?
we follow?
Yeah, I would encourage
Uh,
go to this Wikipedia. Even I studied couple of years ago. So if you're interested, I will go through it and maybe next week I will explain. Okay, but if you have some time, I would encourage to go through this KMP algorithm link. I can provide in the chart itself and
yes,
show
yes,
it.
that will be.
Yeah, it is interesting because it definitely improves the performance. If you write the exact same algorithm what we have right now, it won't be scalable. It's not scalable. It's not good for really writing in anywhere. Like let's say you are building something like Notepad. You are building a tool something like Notepad where you want to have this find feature. Your code, the one which we just wrote, is not scalable. It's not good in terms of having very large text. Okay, that is only for work for only small text is fine, but if I'm giving the very big input, it will take a lot of time to get the output. Okay, so that's the KMP, that's the substring index algorithm. It's almost like 8:31. Shall we discuss the second one? Do you still have some time, or if you're okay, we can go to the second one?
Yes, Suresh.
Arshad, is it okay?
Yes, Suresh,
Yeah.
sure.
So second one is super reduced string. Okay. What is this super reduced string? Reduce a string of lowercase characters in a range, okay, A to Z. They already given. The input has only lowercase characters and it is only A to Z. By doing a series of operations, we need to reduce by doing series of operations. In each operation, select a pair of adjacent letters that match. Select a pair of adjacent letters that match and delete them. It is like Candy Crush game, right? If the matches color, if the ball colors are matching, you are going to delete them and give the points to the user, right? The similar way,
Mm.
if the adjacent letters are matching, we have to delete them. Delete as many characters as possible using this method and return the resulting string. Okay, if the final string is empty, return empty string. So let's look at this input. I think I would like to use where is that? I want to use the whiteboard. Let me get my pen. Okay, so you can look at the input and you will see how the output came. Yeah, I found the here. Okay. My system was really slow. Okay, here is inking slate. So what is the input here? The input is A B B B C C. Okay, AABBBCC. Okay, so what we need to do is we need to compare two characters. If they are matching, you can you can delete them.
Pop.
Okay, you can pop basically. Now again these two you can just delete them. Now these two you can't do anything. But now let's take these two. Now you can pop. Finally, the result answer is B, isn't it? Let's see. The output is the super reduced string is B, right? So let's see the next one. AAABCC AAABBBCCC, right? BCC, sorry, BCCDDD. BCCDDD. So now let's see these two, right? Let's see, let's take another color. So these two are matching. Now it becomes A, B, C, C, D, D, D. Now again, if you compare these two are matching, these two are not matching, these two are matching. Let's tackle these. Now what happens? A, B, D, 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 right? Now these two are
Yeah.
matching. Now A, B, D. That's the ABD, right? So how to do this basically? So there is another possibility here. I think we are not discussing. Let's say input is like A, B, C, C. How about B, D, D? Now what happens is these two are matching, right? Now it becomes A, B, C, C. These two are matching, so this C, C will go. Now B, B, D, D. Now these B, B are matching. So because these two became adjacent, right? This B here and this B here,
Mm.
they came closer. Once they came closer, you just cancel it and just cancel it. Finally, A is the answer, right? So how
Yeah.
can we reduce super reduced string? What is the algorithm? So because we need to pair, we need to do these two pairs, these two pairs, these two pairs. You can do that, and then again you need to do these two pairs, right? So how long you have to do, right?
Until last index value of string.
Until last index value of the string.
String.
Okay, but again,
So
like
can we use
yeah,
recursion?
yeah, it looks like it's a recursion, but what is the stopping condition? We need to look for the stopping condition, right? If you're going for recursion,
Mm.
yeah. So until every time you need to go through the string saying this is the, let's say this is ABD. So now you, so here there is no more pairs that you can cancel. So that could be the stopping condition. So let's look at the, even I forgot the actual solution. I can look at here and show you. So super reducing here given string, and here is super reducing. Let's see how I'm doing. I did way back. So first one is taking the length. Second one, length is 0, empty string. Length is 1. Okay, return the string. Basically, you
Return.
can't do anything. If the length is 1, you cannot reduce anything. Now, here is the loop actually. It's kind of, you're right actually. We are using a stack here. That's a good idea to use stack. Hmm. Interesting.
Hack. Mm.
Let's see. So, let's see how the logic is. I'm just looking at now. So while next, basically we took two variables. One is current, next is the next variable. While next less than length, In next variable is as soon as long as this is less than the actual length of the variable, length of the string, we are doing. Next one is current equal to start of next. If the current value and the next value are same, what are we doing? We are doing current equal to next plus 1, next equal to current plus 1. Interesting. Interesting. Next equal to current. Okay. Else, if start dot count greater than 0, oh, start dot count is basically stack. Stat dot count greater than 0. Dot- Okay, start dot peak equal to current. Okay, pop, otherwise push, otherwise push. Current dot equal to next. Okay, 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 okay. Now I got it. Now I got it. Current equal to next. Okay, current equal to length minus 1. Current equal to length minus, what is the current? Okay. If current equal to length minus 1, okay, start dot count is greater than, okay, pop, otherwise push dot current. Okay, empty string, characters. Okay, result equal to new characters and pop. Oh, okay, okay. Now I got the algorithm. Okay, let's see how we are doing. Okay, so we are using a stack. Stack is the best structure, data structure for this purpose. Okay, let's see how we are doing. Okay, A B B B C D. Let's see. I'm going to arrange A B B B C D. What is the first character? A B B B C C. Okay, CC. Okay. So what we're doing is we are taking the variables. Okay, let's go through the algorithm and take the variables. Okay. First one is length. What is the length?
Length of string.
One, 2, 3, 4, 5, 6, 7. Right? Length is
Mm.
7, isn't it? Next one is next character.
Yes.
Next one. Let's go through the next one. Next variable current and next. We need to take two variables called current and next. Current equal to, we took with 0 and next is 1. So current equal to 0 and next equal to 1. That means we are comparing these two values. Okay, this is 0, right? Let's take indexes. 0, 1, 2, 3, 4, 5, 6. Okay, so the basic idea here is, if the two characters are matching, okay, if a and a are matching, next what will become is we need to compare these two, and this becomes current, and 2 becomes current, and 3 becomes n equal to c equal to 2, n equal to 3. Now these two are matching, then we will go and compare these two, something like that. Let's see, these two are not matching, right? Now what we do is we will put them in a stack. Put them, I think, is it one? Let's see, is it, yeah, if they are not matching, what we do is, if the stack count is greater, oh, okay, if the stack already have something, we need to pop and compare. If the peak equal to current and pop, if not, we are going to push the current. I see, okay. So what we do is, so this is current, right? So this is current, this is next, they are matching. Okay, let's cancel those and compare these two. This is current and this is next, these two are matching. Okay, let's cancel those. Now this is current, this is next. Now what happens is this did not match, right? Now what we do is we will just put the current value into the stack. Now what happens is we will compare these two. These two, now we should not jump to the next two elements. We will jump. This will become current and this will become next. Now current is C and next is also next to C. Those two will be cancelled. Okay. Now what will happen is there is no more elements in the given input string. Now what we do is we'll pop the elements from the stack and we'll create the final array, which is B. final string. Okay, so this is the algorithm. So let me go back with one more sample to understand. Okay, let's go back to this sample where second one AAA BCC DDD AAA BCC DDD AAA BCC DDD, right?
Mm.
AAA BCC DDD. The output should be, we'll figure out the output. Okay, so let me walk through the algorithm. So what we do is, let's take 0 1 2 3 4 5 6 7 8. So the length is 9. Now first one is current will be 0, next will be 1. That means these two, this is current and this is next, right? Both are matching. Let's cancel those. Now this is current and this is next. A and B. Did they match? No, right? What we do
No.
is, in the array we will put the value of the current. What is the value of the current?
2.
No, not
A.
value, the character at the current position. The character at the current position.
A.
A. We'll put the A because it did not find the match. It is a culprit. It could be a character that will be in the output. We don't know yet. We don't know. There could be another A in the down the line that can get cancelled. But for the time being, we are putting A in the stack. Okay. Now at this point, we will just increment. In this case, we are incrementing by 2. The current will be incremented by 2. Next will be incremented by 2. But now, since you did not find the match, we just increment by 1. That means current becomes 3 and n becomes next one. So we are comparing these two if they are matching, right? Are they matching? No, right?
No.
No.
Now what we do, we have to put the which value? The current value. What is the character at the current?
B.
B will go to the stack. Now we will increment current and next. Now current is pointing to the C. Next is pointing to the C. Did they matching?
Yes.
Yes. So cancel those two. Now increment current by 2. That means 4 plus 2 becomes 6. Now and increment n by 2. Basically, next will become 7. Are they matching?
Yes.
Yes. So cancel those and increment current by 2. That means current becomes 8. This is current.
8.
And n becomes 9. N is like out of the bounds. N is already n becomes basically 9, which is not even in the string, in the given string. At that point, if the current is pointing to the last element, if the current is pointing to the last element, there is no matching for D. Simply put that value in the stack. That's the extra condition. You can see that extra condition here. If the
Suresh, one thing I want to add, before placing in stack, we can check whether the last element in the stack and the element which we are keeping
Hmm,
are same. If then we can pop out the last element in the stack.
that's exactly what is happening here. That's right. That's perfectly right. So before we push to the stack, we will see what is in the top of the stack. Okay. The reason is, let's
Yeah.
say, let's say, yeah. So let me
A
finish
B
that.
B
Let me
A
finish. Let me finish. I
A
think
B
I think
B
what
A
you said is correct. Let me finish this. So for this input, this is the changes, right? For this input, we are not going into that case. Now we completed the scanning the entire string. Now we need to pop each element from the string, but we need to put from the ending of the string because they are in a reverse order, right? So we need to take the length of the stack is 3. We need to take 3 characters and put the D at the last, and then take B at here and take the A and here. So the ABD, that's the answer, right? That's the answer here. ABD.
Yes.
Now coming back to the Arshad scenario. Arshad said one scenario. Let me put something like this: A, A, B, C, C, B, D, D. Okay, look at this. These two are matching. This A is not matching. Okay, these two are matching. These two are matching, but these two also matching. Very interesting here is the interesting part here is these two are matching, but they are not adjacent each other. They will match after you put it in the stack. So what he is saying is, first what we do, this is current, this is next, matching, cancel. Now this is current, this is next. Are they matching? No. Put A in the stack. Now, now this is current. Now this is current. This is next. Is both are matching B and C? No, matching. They are not matching. So put the current value in the stack B. Now this is current. This is next. Is C and C matching? Yes. Right. Now we don't put anything in the stack. Now what happens is, now this is current. This is next. Current is B, next is D. Are they matching? No, they are not
Yeah.
matching. But in this situation, what we do is, what are we doing? If there is not matching, if the characters are not matching, we are simply putting the current value in the stack. What Arshad is saying is, before you putting that character, check the value of the character which is already on the top of the stack. The top of the stack is B. This B is matching with the character that you want to put it there, right? So then just pop out the value. No need to put B and B, because it cannot be answer like this, right? This should not be the answer, because B and B could be cancelled. So before you putting something in the stack, check what is the top of the stack. If the top of the stack and the element that you want to put are same, okay, that's the condition. If the top of the stack and the element that you are trying to put into the stack is same, just cancel or pop that element. Okay, don't even put the extra B and pop the existing B. That is the condition. Okay, done. We are done with that. Now current pointed to D, next pointed to D, both will be cancelled, and now current is out of the string and n is also out of the string. We are done. Finally the answer is A. For this given input, the answer is A. Did you follow, Tarun?
Yes, Suresh.
So that is the main logic here. So this is the best use of the stack. Very best use of the stack. The reason, the what is the complexity here? The beauty of this algorithm is complexity. What is the complexity of this algorithm?
Order of n.
Simply order of n. We are just navigating only once. We are just taking two variables, current and next. We are intelligently managing those indexes, and we are navigating only one time. But Tarun, if you said the recursion or any other approaches, you need to process once, you need to
Mm.
process again, 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 until you find a situation where you cannot process anymore. So you need to start from the beginning multiple times. So it could be more than order of n, right? Because if you are just checking these two and then canceling, what will become is, it will create substring. Again you need to start and process, right?
Yeah.
So that could be definitely not order of n. So let's say in this example, right, what happens is you cancel a. Now a, yeah, in this given example, what will happen is, it will create a here, and create b, and it create b. So that's the first iteration. You do that because you cancel these two, you cancel these two, you cancel these two. Now ABB is the iteration. Again you need to start from the beginning, and you have to see, is AB matching? No. Is BB matching? Yes. Now you end up with A. So it's a three iterations. You need to start from beginning to the end, three iterations. But in our case,
Mm.
we are using intelligently, we are using a stack, and we are putting everything in the stack. It's an order of n. We are not processing the string multiple times. Okay, that's the algorithm here. Very good algorithm.
What the approach we thought is like in Java, if we pop the element, the string, the data will be erased. So the again we can do from starting, and if we find any pair elements, we pop it, and we'll pass that array to next recursion. Yeah.
Yes. Actually, recursion uses the stack behind the scenes, right?
Yes.
That's what it is. So we are using stack rather than using recursion. So that's the only thing here. So yeah. So look at yeah. If you look at the algorithm, you can easily understand. So first one is current and next, and here is the length. Like as long as next less than length, that's the condition, right? As long as next is less than length, we will go ahead. But current, if the current becomes length minus one, if the current is the last element, that's a special condition here. So first condition here is as long as next less than equal to length, and we'll see is the current value and next value are same. If the current value and next value are same, current becomes next plus one. Look at this. This is like jumping the two indexes. It's not current plus one.
Yeah.
Current equal to next plus one. So because let's say 0 and 1, 0 character at 0 and character at 1 is already matching. The current becomes 1 plus 1 becomes 2. So it's like jumping two indexes, and next becomes this current plus 1. That's what it is. So if this is exactly something like this, these two are matching. So now current becomes next plus 1, current becomes 2, and next becomes current plus 1, next becomes 2 plus 1. We are jumping two indexes. Otherwise, let's say if they are not matching, now this is the condition. This is the condition, as Arshad said. First we need to check what is the stack. If the stack count is greater than 0, that means stack already have some elements. If stack already have some elements, we need to see what is the peak value. We are not going to remove it. So pop will remove the element, and peak will give you the top value. It won't remove the element, it just give you the element. Okay, what is the top element? If the top element is matching the element that you want to put, you want to put b. Okay, here you want to put b. You put b here. Now in the second b, whenever you're trying to put this that second b, there is already a b here. So why don't you just pop this b rather than putting a b b? We just pop it if the top value is matching the value that you want to put, because the current did not match with the next, right? Since the current did not match with the next value, we are trying to put the current in the current character in the stack. But before putting, we are checking the value of the top element. If the top element is matching, simply remove the top element. If not, push the top element to the stack. That's the condition. And then this is another condition. Let's say the first, if the stack does not have any elements, then simply put that first element as a push. You just push the current value into the stack. This is simply checking for the stack. Now what you do, look at this condition little different. Now current equal to next, next equal to next plus 1. These two conditions are different. Here we are jumping two indexes, but here we are jumping only one index, because you put the current value, the character at the current in the stack. You just need to take the next value, and next becomes next plus 1, like this, right? You put
Yeah.
a into the stack. Now this becomes the current, and this becomes the next. So you're not jumping two indexes out, right? So now next value becomes current value, and current becomes next plus 1. Are you clear so far? Okay.
Yes, Suresh.
So now here is another last condition. If in case current becomes length plus 1, length minus 1, that means you end up with a last character which is not, there is no next character to compare, because next is already out of the bound. So similar situation I think we encountered here, right? So next is already here, which is out of the string, but current character is d. So you need to put the d into the output, right? So that's what it is. So again, if that d is matching any of the peak element, remove it. Otherwise, push into the stack. So finally, you after this, we completed full round of putting everything into the stack. Now we will compare. If the stack count is empty, by any chance you did not put anything into the stack, that means empty string. There is nothing. So you cancelled everything. Let's say input is like this: a b b b. A will be cancelled, b b will be cancelled, right? And there is an empty string. So if the string is like this, a b b, empty string is the answer, because you did not put anything in the stack. If otherwise, if the stack is count is not empty, then what we need to do is we need to take a result character array, and we need to initialize with string stack dot count, because how many characters in the stack, that will be the characters of in the output. And we need to put in reverse order: I equal to stack dot count minus 1, and while stack dot count greater than 0, stack dot pop, put it in the I minus 1. Basically you need to put the elements in a reverse order, because the stack always put on top of each other, right? So you will, first character will be at the bottom of the stack, right? That's why we are putting
Yeah.
in a reverse order. This while loop will put the values in reverse order. Let's say this is the one ABD, right? You initialize the stack with three characters, and then put the D here, and then B here, and then A
Last
here.
index.
Got it?
Mm.
Because you take the elements from
Yeah,
the top.
Suresh.
Yeah, I will take this, I will take this, and then we'll take this. So finally that will be the output. So it is not easy to write in an interview, but definitely this is a very good algorithm where you can utilize the stack. So if you're able to explain at least some parts of it, that would be enough. Okay, this is super
So
reduced.
is in calculating time complexity, you don't consider that adding elements in stack.
Time complexity, yeah, stack time complexity. We need to um, it's not
It
navigating, right?
is
You are not navigating anything. You are, that's order of one. Always like stack, putting element into the stack and removing element from the stack is order of one. You are not navigating anything, right?
Yeah.
But of course, the complexity will be added here. Let's say the input string is, you say, because you have another while loop here, right? So let's say the input string is 7 characters, not 7. Let's go back to here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 characters here, and then out of 9 characters, you put 3 characters in the stack, and you are looping these 3 characters. Finally, 9 plus 3 equal to 12. So it is constant. Basically, you're not exponentially increasing. Basically you're navigating the given input, all the characters, 9 characters, and you are putting the output in a stack, right? And you are looping this. Of course, you are removing the characters from the stack and putting in the final array, right? So that will be another constant time. Even let's say 9 characters are completely unique: A B C D E F. A, B, C, D, E, F, G, H, I, J, K, whatever, 9 characters. What do you do? All the 9 characters you will put it in the stack, and you remove, and a while loop will be go. So it will be like 9 plus 9, 18, which is order of 2n. 2n means n. Worst case is worst case is 2n, right?
Yes.
All the characters you will put it in the stack, and you are removing all the characters out of the stack. So 2n is always, you can remove the constant, you can say order of n. We are not
Yes.
exponentially increasing the complexity anywhere. Got it?
Yes, Suresh.
Cool. Yeah, that's the algorithms here. I think we had a very good discussion. Please practice more. I will send the links as well. So if you really want to look at right away, here is the algorithm, because it will take for me some time for me to record and download and put it in YouTube, and sending all the links. In the meantime, maybe tomorrow morning, if you want to look at it, you can look at it. Okay. And here is the hacker rank
Okay.
link of this algorithm. Very interesting algorithm. This is exactly similar things what happens behind the scenes in Candy Crush game, all these games, right? Lot of algorithms will work
Mm.
behind
Hmm.
the scenes. Yeah.
Yeah.
Awesome. Cool, guys. How the things going? Everything is good, or did you enjoy this, or any helpful of this session, or what's the feedback? Just want to get some feedback.
It was nice, Suresh.
Really cool. Mm.
Second one, the first one was good. The second one was equally good.
Yeah.
So today both the questions were good.
Very nice, very nice. Yeah. So we have few more questions in string. We'll cover next week. Swapping convert to lowercase, basically swap case. So we always do in Java everywhere use two lowercase, two uppercase, simply. But how to do in a real time? Like what is the logic behind converting? You know, a character, basically a small
Uppercase
character,
is low.
converting into lowercase character. So, and also swap case. Swap case is basically converting from uppercase to lower, lowercase to upper. Okay,
Mm.
and reverse the
I
word.
think we'll deal with ASCII.
Exactly.
We'll deal with ASCII things.
Simply, yeah,
And
exactly. It's
constant
all ASCII
number.
character. Yep, exactly. That's
Yeah.
the swapping with ASCII characters. And next one is reverse the string. Reverse the word of the given string. So how to reverse the string? I think this is very simple algorithm. And text trimming. This is also another thing we'll discuss next time. How to trim the text. Basically, if in a reading articles, we'll say something